Welcome to lesson 2 of 3 in this tutorial, covering energy transfers in everyday appliances. This is our second video in our series of 3 lessons on the topic of energy transfers. Here are the key learning objectives for this lesson. We'll be looking at transferring energy, examples of transfers of energy, work done, and finally power ratings in relation to energy. Here are the AQA specification points for this session. Feel free to pause the video now and read through them before we begin. There are quite a few here. We'll start by looking at how everyday appliances cause energy transfers. Everyday electrical appliances in our homes are designed to bring about energy transfers. For example, kettles, microwaves, and hairdryers can all convert electrical energy into other forms of energy, which we can then use. Now, we will look at how much energy is transferred by these appliances. The amount of energy transfer can vary, depending on various energy factors such as time and power. The length of time an appliance is switched on for is very important. As the appliance tries to cool down, it will convert more of the electrical energy input into a thermal energy output. This is often seen as wasted energy, since it is not our desired output. In this way, the longer an appliance is switched on for, the less efficient it becomes. Different appliances will have different ratings for power. A more powerful appliance will use more electricity than a less powerful appliance. However, we still need to be mindful of efficiency. A powerful appliance might have a less efficient energy transfer. If you are asked to explain the factors affecting the amount of energy transfer, you should bring in ideas about efficiency into your answer. Our next specification point is to describe how different domestic appliances transfer energy. In this section, we'll look at 2 types of devices using energy transfers. These are electric motors and heating devices. Electric motors use kinetic energy. Electric motors convert electrical energy from the batteries into kinetic energy. This kinetic energy can be used to spin the blades of a fan or move electric cars. The wasted energy here will be mainly in the form of sound and thermal energy. Heating devices will convert electrical energy from the mains alternating current supply into thermal energy. This thermal energy can be used in the heating element of a toaster. The wasted energy here may be in the form of sound energy. If you are asked for the wasted energy in an example of an energy transfer, normally your best bet is to say thermal energy. Most energy transfers will give off heat. In the case of a heating device, the heat energy is actually the useful or desired energy output. Now, we'll look at when work is done. Work is done when charge flows in a circuit. Previously, in the energy section of this course, we defined work done as energy transferred. Our next point is to look at an equation involving the transfer of energy. We can calculate energy transferred in one of 2 ways. Here, we'll use power and time. Power tells us the energy transferred per second. To find the total energy transferred over a sustained period of time, we need to multiply by the power by the total number of seconds. This is the short version of the equation, which is acceptable to use in an AQA exam. The units for this equation, as shown here, are watts, joules, and seconds. You need to understand these equations because otherwise you will struggle to answer the more complicated exam questions. Let's have a go at this practice question. Pause the video now to have a go at it by yourself. The answer is 50 watts. Let's see how we got there. In this instance, we need to write out our appropriate equation and rearrange it to make power the subject of the equation. So here we would write out energy is equal to power multiplied by time, so power is equal to the energy divided by time. Now we can substitute in our numbers. So power is equal to 400 joules divided by 8 seconds, giving us an answer of 50 watts. You need to be able to work out the power from either time and energy or current and resistance. Then you can use these values to compare items such as household objects. Pause the video now to attempt this next question on your own. This is the answer. In this instance, we haven't had to rearrange the equation, so we could simply put in our numbers. The only thing we have to watch out for in this example is that we have to convert 1 minute into 60 seconds. It's crucial that you remember to convert your time from minutes into seconds. Students always make mistakes with units, so watch out. Here's another exam question. Feel free to pause the video now to attempt this question before we go through it together. Here, we had to work out the difference in power, which came to a value of 4 watts. Then, we had to convert our time into seconds, so we multiplied 120 minutes by 60 seconds. Finally, we used our equation for energy transferred and converted our final answer into kilojoules. It saved time to work out the difference in power, which was 4 watts in the last question, and then plug this into the energy transferred formula to find the difference in energy transferred. This meant we didn't have to do a separate calculation for each lamp. Now we will cover another equation to do with energy transfer, this time linking it to charge flow. We can also calculate energy transferred using charge and potential difference. Let us look at the first equation, E is equal to P times T. We can substitute P equals VI into this equation. This gives us E is equal to V multiplied by I multiplied by T. Current is just the rate of charge flow, so I is equal to Q over T. We can also substitute this into our equation. This gives us E equals V multiplied by Q divided by T times T. This will further simplify into E is equal to V over Q. This is because the T's cancel out. Therefore, E equals P multiplied by T becomes E is equal to V multiplied by Q. Again, don't just memorise the formulae, you need to understand them. We know you want to focus on things included in the specification, but we promise that understanding these formulae will help you gain a much higher score. Now let's look at energy transferred. It is the conversion of energy from one form to another. This can be defined by this equation. Here's the short version of the equation, and here are the units. Let's have a go at this question to put our knowledge into practice. Pause the video now to attempt it on your own. The answer is 720 joules. Let's go through it step by step. First, we need to write out our equation. In this instance, our appropriate equation is E is equal to Q multiplied by V. In this question, we've been given a time in minutes, therefore we need to convert it into seconds. We know that 1 minute is equal to 60 seconds. We need to use our value for time in seconds when we substitute in our numbers. We calculated this in step 2, so E is equal to 12 watts multiplied by 60 seconds, giving us an overall answer of 720 joules. You need to be able to convert between units, such as joules, kilojoules and microjoules. This can be applied generally to all other units too, especially those of time. Our final specification point looks at examples of energy transfers in domestic electrical appliances. When a customer buys an electrical device, it comes with a power rating. This is the maximum value at which the appliance can be used safely. We also know that power is the rate of energy transfer. Therefore, the power rating also tells us the maximum rate at which energy can be transferred when using the appliance. A higher power device will transfer more of the stored energy per second. Therefore, it will require more electricity. The concept of energy efficiency is important to remember here. Although higher power devices may have a high energy transfer rate, not all the energy may be transferred usefully. A low power rating is just the exact opposite of a high power rating. Try to work out what this means in terms of electricity use. We've now covered all the specification points for this tutorial. Feel free to skip back through the video to re-watch anything you are unsure about. We have now completed Lesson 2.